Hi grade 8, Assalamu alaikum. Welcome back to the physics classroom. Today we are going to solve the exercises on page 110, 111 of the textbook. The first exercise was to copy and complete the statements. The oscillations of the pendulum of a clock, the rotation of the earth about its axis, the to and fro motion of the windshield wipers are all what type of phenomena? Yes, they are periodic phenomena. A sound emitter has what type of motion? It has a vibratory motion. The watt of a periodic motion is the minimum time after which it repeats itself. The period of a periodic motion is the minimum time after which it repeats itself identically. A mechanical wave is characterized by its three things: its period, its amplitude, and its speed of propagation. The second exercise was to choose the correct answer. Each statement is followed by three answers. Two are incorrect and one is correct. A mechanical wave transports 1. Matter with energy, or matter without transport of energy, or energy without transport of matter. That's correct. A mechanical wave transports energy without transport of matter. So the matter stays where it is while the energy moves along with the wave. The wave in which the particles of the medium are moved perpendicular, that's right angles, to the direction of propagation of the wave is transverse, longitudinal, or circular. That's correct, it's transverse. Now we'll continue with the exercise 2. The frequency of a periodic motion is the number of periods per. Is it second, minute, or hour? A good way to remember this is that what is the SI unit for time? And it is seconds. So this will help you remember that the answer is second. A disk that rotates 10 revolutions per second has a period. If we recall that the period is 1 divided by the frequency, and here we have 10 revolutions, so it's passing through 10 times in 1 second. So the period is 1 divided by 10, which is 0.1 seconds. Now we move on to exercise 3. We have a long spring and it is stretched between two supports. We compress a few loops near one end and suddenly release them. You can see very clearly that there is a compression moving through the spring. So we have the loops are all these circles in the spring, and as we compress it from one end, the compression starts to move through and produce a wave. What is observed along the spring? We mean, what are these that we see going across the spring? We observe the propagation of a compression. So this is what we mean by this. It's making a compression along the spring. Is the mechanical wave propagating along the spring transverse or longitudinal? When we have to decide if it's transverse or longitudinal, we have to think of the particles. Are they moving perpendicular to the propagation of the wave, or are they moving parallel to the propagation of the wave? You can see here that they are moving with the wave. The compressions here are moving with the waves. So we say that it's longitudinal. So it is longitudinal wave since the displacement of the spiral, these are the spirals or the loops, is parallel to the direction of the propagation of the wave. What can be said about the position of the loops after the deformation passes? So after the loops, this deformation passes, what happens to the others? The spirals go back to their original equilibrium position. So we all know that a clock has 3 hands. Here we can see the hour hand, and the minute hand, and the second hand. So each one of these hands on the clock needs to turn 1 full turn till it gets back to where it started. So when we want to consider the period of each hand, we have to recall what a period is. A period is 1 cycle or 1 rotation. So 1 period is for the hand to go, the time needed for the hand to go all the way around and back to where it started. So each one of these hands takes a certain amount of time to do so. And you can see it here in this animation. The hand is going around and round and round, and you can see that the minute hand is a lot quicker than the hour hand. The hour hand hasn't made a complete rotation yet. So the period of the hour hand is 12 hours. This hand here, the hour hand, needs 12 hours to do 1 full rotation. The period of the minute hand is 1 hour or 60 minutes. It needs 60 minutes or 1 hour to go all the way around and back to where it started. The second hand needs 1 minute or 60 seconds to go around and back to where it started. So 1 full rotation is 1 minute or 60 seconds for the second hand. So if we want to calculate the frequency of rotation of each hand, we need to recall that the frequency is equal to 1 divided by the period. Let's all recall that the period is a measure of time, and time in SI units is measured by the second. So these periods that we have up here, we have put them in hours and then in minutes. So in order to calculate the frequency, we need to convert this into seconds. So for the first one, the frequency of the hour hand, we put 1 divided by 12 times 3,600, because there's 12 hours, and in each hour we have 3,600 seconds. So we end up with a frequency of 0.000023 Hertz. The frequency of the minute hand is 1 divided by 3,600, because it is 1 hour, and 1 hour is 3,600 seconds, which is equal to 0.00028 Hertz. The frequency of the second hand is equal to 1 divided by 60, because 1 minute is 60 seconds, which is equal to 0.0166 Hertz. Exercise 5. A mechanical wave moves along a spring. It covers 5 meters during 0.5 seconds. Calculate the speed of propagation of the wave along the spring. Now, in order to calculate the speed, we need to use the speed or velocity formula. And we all know that the speed of anything is the distance covered divided by the time taken. In this case, we have 5 meters being covered in 0.5 seconds. It is important to make sure before inserting any numbers into the formula to make sure they are in SI units. In this case, we have 5 meters and 0.5 seconds, which are SI units. And the speed of propagation is 10 meters per second. Do not forget the units meters per second, since that is the SI unit for speed. Thanks for watching grade 8. See you next time in the physics classroom.